algebra, we are moving on in unit number 4 with a new form of a graphical equation. We've talked about slope-intercept form and the advantages that slope-intercept form gives us. What does slope-intercept form tell us about the line that we graph? What's the important information from slope-intercept form? Why we call it slope-intercept form?
Because it has the slope.
Gives us the slope at m, right? And, Katie? Gives us the y-intercept, thus slope-intercept form. We also talked about standard form, which isn't really helpful for graphing. It does come into play later on. We'll get to that in a few units. But that's ax plus by equals c. Today, we're going to talk about another graphical equation called point-slope form. And the advantage of point-slope form is that when your y-intercept is like a fraction, it's like 1 in 5/7. It's not really easy to plot 1 in 5/7 on the corner plane, right? If you'll remember all of our slope-intercept form graphing equations, b was a nice round integer. -3, +5, +0, right? Sometimes you will get a y-intercept that doesn't cross at an integer spot. And so it can be difficult to plot. Thus we have point-slope form. And point-slope form looks like this. Let's do, y minus y1 equals m times x minus x1. Remember those lowered numbers like that are not powers. It's not y to the first power, which is just y. It's like our slope formula, y2 minus y1, that situation. Y minus y1 equals m times x minus x1. And like slope-intercept form, each of these has its purpose. The one we recognize, of course, is m. And what does m represent?
Slope.
The slope. That's true here also. That's why it's called point-slope form, right? It gives us the slope. But the difference is, instead of the y-intercept, point-slope form gives us another point somewhere on the line. Okay, so y1 and x1, y1, notice I'm skipping down here, so don't write this in the first y spot here, go down to y1, but y1 is the y value of a specific point on the line. And the key word here is specific. Okay, it's a specific point on the line. Kind of like the y-intercept is a specific point. Y1 is the y value of a specific point. And x1, as you can probably guess, is the x value of a specific point on the line. And again, the key word here being specific. Okay? This is not going to be the y-intercept. It's going to be some other point out in space, but it is a specific point that's on the line. Then, just like slope-intercept form, the other y and the x, just y by itself and x by itself. Y, would you remember what y was in slope-intercept form? Y equals m. What was that y, yeah?
Was that the y value of any ordered pair?
Yes. The y value of any ordered pair on the line. The key word here is any ordered pair. Not a specific one, but any ordered pair. Any ordered pair on the line, you plug it in for x and y, and it would make the equation true. Same thing here. The x value, or x variable, is the x value of any ordered pair on the line. Again, keyword any. Okay. So, what does this form tell us about the graph of the line? It gives us the slope. That's important. That's helpful in graphing. And it gives us a specific ordered pair. And again, this specific ordered pair is not the y-intercept. Okay? If it was the y-intercept, it'd be in slope-intercept form. But this is point-slope form. It's a specific ordered pair that's not on the y-axis. And again, the value of this is that if your y-intercept is something really funky, okay, where it's like, 1.93, good luck plotting 1.93 accurately, right? It's tough, okay? Or if your y-intercept is, plus 1,000, you're not going to make a chorded plane that's 1,000 units high and put your point there. This is another way to graph an equation, right? When your y-intercept is not very helpful. Okay? So let's look at some examples. Any questions on these notes first? Cole?
Is it ordered?
Yes. Ordered pair. A specific ordered pair. Right. Let's see. Okay. Just like with our slope formula, we do need to pay attention to those subtraction signs. Nathan, warning for you. All right. Warning for you, Colin. We do have to pay attention to those subtraction signs in the equation, and we'll tackle that a little bit here. It says, write the equation of the line described in point-slope form. For the bottom three, show how you calculate the slope. So again, here's point-slope form. Y minus y1 equals m times x minus x1. Okay? And when I give you the slope, I tell you it passes through 6, 4. The slope is your m. We're familiar with that one, right? That 6, 4, this is going to be that specific ordered pair, right? 6, 4 is very specific. It's not just any ordered pair. It's a specific ordered pair you're told the line passes through. So here's going to be your value for x1 and y1. And with that information, you have all the pieces you need to write this equation in point-slope form. Y minus 4, that 4 coming from the y1 value, equals your slope of 7 times x minus your x1 value, which is 6. There you go. That's it. So how we graph this, that's what CO27 will get into, how to extract that ordered pair from point-slope form. But just if you're given a specific ordered pair, such as this case 6, 4, and you're given the slope, okay, plug that y1 value in, plug that x1 value in, plug in your slope, and you get y minus 4 equals 7 times x minus 6. Where kids get tripped up with this is that in this ordered pair, both 6 and 4 are positive, but in the formula, they look negative. And the reason for that is because the formula's got the negative signs in there. Right? Yeah.
Okay, I have a question for the next equation.
Okay.
When it's subtraction, then does it become addition?
Yes. So the next one here, again, we've got our m, right? There's our slope of 1/3 there. The specific ordered pair, negative 2, 1. Here's our x1. There's our y1. And so plugging these in now, y minus y1, or y minus 1, is equal to our slope 1/3. And what Matt is asking here is, since this value for x1 is negative, how is that going to interact with the subtraction sign in the formula? It changes it to addition, right? It actually looks like this. X minus our x1 value is negative 2. So it looks like x minus negative 2. But as we know, as we learned from the slope formula and other things that we've done previously, when you've got that minus a negative, that's actually addition. Okay? So you should write it, I'll do it below here, y minus 1 equals 1/3 times x plus 2. Because subtracting that negative value actually switches it to addition. Yeah.
So in point slope form, negatives are positives and positives are
In point slope form, a positive value in the ordered pair is going to appear negative in point slope form, and vice versa also. We'll get more into that when you actually graph them. But yes, yeah.
For the bottom ones, can you use any of the ordered pairs?
Yes, we'll get to that in a little bit, but yes, you are correct. Okay, so for the next one, where both of these values are negative, both x1 and y1 are negative, what symbol, what operation will be in our formula when we plug in y1 and x1, Cole?
Do you have a Band-Aid?
Yes, I do. Can I ask how you cut yourself?
Well, let's go back to yesterday. I don't know what
From yesterday?
happened.
So since both of those values in the ordered pair are negative, what signs, what operation are we going to have in our formula? Manny. Addition. Okay? Our slope is still -5 here, right? X1's -8, Y1's -4. So y minus y1, y minus -4 is actually going to be y plus 4. And then our slope of -5, x minus x1, since x1's negative, it's actually going to be x plus 8. So back to Tristan's questions, in point slope form are negatives, positives, and positives, negatives. In a sense, you know, that -8 becomes positive in the formula, the -4 becomes positive in the formula. Back in the first example where it was a +4 in the ordered pair, it appears negative in the formula. That +6 in the ordered pair appears negative in the formula. Okay? So you can think about it like that, sure. Questions on this? The formula itself. So in the bottom 3, I don't give you the slope. Uh-oh. What do we do? Paul. We find the slope. How do we find the slope? Right. Our good old slope formula, right? X1, Y1, X2, Y2, plug them in, get that slope. Will, do you need to leave again? Show me that you want to stay here. Have you been following along with the notes? Cool.
It's x2 minus y1, and then y2 minus y1. Y2 minus y1.
Yes.
Yeah.
Y2 minus Y1 over X2 minus X1 is our formula for slope, right? So plugging these things in, Y2 minus Y1, 4 minus 6, X2 minus X1, 9 minus 3. We get -2/6, which equals -1/3. And that's going to be the slope of this line. Eli.
Once you do the slope, can you use either of the ordered pairs?
So now that we have the slope, the only thing that we're missing is that x1, y1, that ordered pair, that specific ordered pair. Eli's asking, can we use either of them? Does it matter? And it doesn't. Okay? So you can technically have 2 answers for any of these bottom 3 here, where I give you 2 ordered pairs that the line passes through. You could, if you use the first ordered pair, let me do this in different colors so we can keep track of the notes here. If you're using 3, 6, your equation is going to be y minus 6 equals your slope that you found, -1/3, times x minus 3. Right? They're positive in the ordered pairs, so the subtraction signs in the formula makes them appear negative. If you use 9, 4, you could also have, as the second answer, y minus 4. Your slope won't change, because that's constant, regardless of which ordered pair you pick from the line. But then x minus 9. Right? So either ordered pair works. Either answer would be considered correct on a test, because you are using the slope and a specific ordered pair from the line to find it. Paul. We will get there in just a second. Okay? Questions, comments, concerns, complaints, comments, congratulations, criticisms so far. Cole.
You can simplify the fraction.
You should simplify the fraction. Colin.
Do we have a math test this week?
Will there be a math test this week? No. Nope, there will not be. So your brains will have to recall this information after Christmas break. But I think you can do that. Tristan.
Is there gonna be time during this week where we do retakes?
I'm here after school today for retakes, but that's going to be the only in-class time, I think. Because tomorrow we're going to do another lesson, probably. Wednesday is going to be kind of a funky day, so yeah. Okay? Manny,
Is math on Tuesday or Wednesday?
I believe it's on Wednesday. Pretty sure. Leah.
Are we gonna like dream or like what are we gonna do like that? Are we out of uniform on Wednesday?
I believe we are. Wear something snazzy.
What?
I don't know for sure. I shouldn't say this out loud because I sometimes don't know what I'm talking about. Paisley.
I thought Wednesday was cozy day. Yeah.
I don't know. Let me confirm with people that know more than I do, namely any of the other teachers in the school, and I will come back to you.
I don't know what bus didn't come.
All right. 8th grade algebra. Your homework will be to finish the rest of just these two. Trust me here. 8th grade algebra, your homework is just finish these other two that we have not done. So you can end the video now and go on with those. 7th grade algebra, and anyone from 8th grade who wants to, a little bit more of a challenge, your homework will include the bottom part where it says rewrite the following equations in slope-intercept form. Okay? So these are given to you in point-slope form, and your job is to convert them into slope-intercept form. Basically meaning you get to get y by itself. Okay? Now I heard someone say, it's so easy. Someone who thinks it's easy, share with me how you got to the answer. Caleb.
So since you already know your you already know your slope and you already have your ordered you went for y and x.
Hey folks, we are still recording. Go ahead.
Since you know your slope is 2, and then you know now with your ordered pair you know your y and your x, then you fill your y and x to get your in the equation to get your v, and then you can just.
Sure. So Caleb's saying, what do we need to write an equation in slope-intercept form? We need the slope. We need the y-intercept, right? Point-slope form gives us the slope, and it also gives us an ordered pair that we can plug in to solve for b, just like CO24 from the last unit, right? What's the ordered pair that this equation gives us? And this is kind of jumping to tomorrow, but yeah.
-3, 7.
Good. Remember, the sign you see in the formula is the opposite of what's in the ordered pair. So this +3 and that -7 in the ordered pair will actually look like -3, +7 with the slope of 2. Right? And we'll get more into this tomorrow. So if this doesn't make sense, don't worry. There's another way to do what Caitlin described. So this is kind of jumping ahead a little bit. But once we know the slope of 2 and we've got that ordered pair, we could plug those things in to slope-intercept form and solve for b, just like PO24. Leah, this part is homework, yes, for you folks. Algebra 8, they get to stop at the top. The other method, okay, is remember, slope-intercept form is simply, folks, is simply y by itself. And so the other method would be to distribute the 2 into your parentheses to get y minus 7 equals 2x plus 6. And what do we need to do to get y by itself? Add 7 to both sides. So that 6 becomes a 13, and there's your answer in slope-intercept form. I absolutely love, Caitlin, how you made that connection to do this here. This might be a little bit more efficient, okay? But that other way works too. That was awesome.
Yeah.
I'm super impressed that you made that connection. Okay? All right, Nick.
I get from 6 to 13 in the equation.
I added 7 to both sides
I have a question.
to get y by itself. Okay, this answer isn't done yet here, right? You still have to finish it out. If you're doing this method here, you'd multiply 2 and -3 to get that -6, and add 6 to both sides to get 13 as your value for b there, which is the same thing that we got there. So for most of you, I would recommend doing what I do in red, distribute, and then get y by itself. Okay? If you want to, you can pull that specific ordered pair out of that formula though and do CO24 to get b that way too. Whichever one makes more sense to you is fine with me. Leah. So for the second one, folks, Ryan, Nathan, no. For the second one, to distribute that 2/5 in, you're getting y plus 2 equals 2/5 x, and then what's 2/5 of negative 10? -4. Right? Now, to get y by itself, you're going to subtract 2 from both sides, and y equals 2/5 x minus 6. There's your equation, slope-intercept form. Sam, did you follow any of that?
Yeah. We do the next one too.
Doesn't look like it. No,
No, I think
you need to do the other two on your own.
Wait, so is that the answer?
Yes, you're looking to get into slope-intercept form.
Do one more.
Nope. You can do the rest, or rewatch the video for 2 examples.
I finished.
Okay? Finn, morning for you. I need you to be quiet while we're recording. Okay? Any other questions? Other than, can I do another one? Okay, Cole.
Can you say the verb that song?
No. This is due tomorrow. That's how you math.
Don't forget to like and subscribe.